What is rotational what? Dynamics? Is defined as the motion of a body in a rotational manner, not along. The motion of a body in a rotational manner and the forces that causes what? The motion is defined as the motion of a body in a what? Rotational manner, right? And the forces that causes what? The motion. Right. Note that in linear motion, force causes what? Motion. Are you there? But in rotational motion, torque causes what? Motion. Torque. But in rotational motion, torque causes what? Motion. Am I communicating? When you hear the word torque, what does torque mean? Any force that causes a body to rotate is called what? Torque. No longer called what? Force. But torque is an equivalent, let me say, parameters with what? With force. Are you there, somebody? What I say there? Note that torque is what? An equivalent what? Parameter with what? With force. Note that torque is an equivalent parameter with what? With what? Force. So for linear motion, what causes motion is what? Is force. Abi? Force applied. But in a rotational motion, what causes a body to rotate is what? Somebody? Torque. Listen, if we are saying that force causes motion and force is mass times what? Acceleration. This is for linear, right? For a body to rotate, what will be? What is that torque here? Torque becomes what? Don't forget that mass represents what? Inertia. Moment of what? Inertia. Abi, what will be here? Somebody? Inertia. This A represents what? Alpha. This is called force. This is called what? Mass. This is called what? Acceleration. Linear what? Acceleration. This is called what? Torque. This is called what? Inertia. Or moment of what? Inertia. Abi, this is called what? Angular what? Acceleration. Are you following somebody? Am I communicating? That means that the equivalent parameter to force is what? Torque. To mass is what? Inertia. To acceleration is what? Angular what? Acceleration. Am I communicating here? Are you there? Okay. Let's define moments of inertia. What is moments of what? Inertia. What is moment of inertia? Please write. This is a measure of the resistance. Moment of inertia is defined as a measure of the resistance that a body offers. Is a measure of resistance that a body offers to having its rotational motion changed. Is a measure of resistance that a body offers to having its rotational motion what? Changed. Am I communicating? To having its rotational motion change. It's called what? Somebody? Moment of what? Inertia. Moment of what? Somebody? Inertia. Now let me take us through a little journey. Listen, moment of inertia. As long as a body rotates, there's always the what? Moment of what? Of inertia. We have moment of inertia of a single point mass. Of a what? Point mass. Number two, we have for a system of multiple what? Particles. Are you there, somebody? Then we also have for a system of what? Definite what? Shapes. Please write. There are three moments of inertia of a rigid body. There are three moments of inertia of a rigid what? Body. Some will say there are four. I will explain the fourth one. There are three. We have one. Moment of inertia of a point mass. Of a what? Somebody. Point mass. Number two. Moment of inertia of a system with multiple what? Particles or masses. Number three, moment of inertia of definite shapes. Definite what? Shapes. With multiple particles. System with multiple what? Particles. Are you there, somebody? Am I communicating? By now you should know what is the moment of what? Inertia, right? Who can tell me again? What is moment of inertia? Right. In a simple term, what does it mean? The resistance that occur in a circular what? So in a what? Rotational what? Motion, right? Are you there, somebody? The resistance that occur when a body moves, rotates, that resistance that occur or that property acquired by that body to resist what? Change in a what? Rotational what? Motion is called what? Somebody? Moment of what? Inertia. Are you getting the concept here? Meaning a body rotating must have to stop because of that property acquired by what? By that body. Are you there? I even give an example last week. I said if you have a tipper and you have a small car, and let's say both of them are accelerating, are you there? And we stop both systems. Between the tipper and the car, which of them will stop first? The tipper. Why? It has a higher mass. So the higher the mass, the higher the what? Inertia. So every object that rotates must have to stop because they possess what? System of what? Multiple or particles or masses. Or what? A point mass. Or what? Somebody definite what shapes. Am I communicating here? Are you there? Yes. Of what? Yes, it's same as rotational inertia. I said it before, right? Rotational inertia is same as what? Moment of what? Inertia. Have I cleared that? The symbol is what? I. Are you there? All right. For a single point mass. What is the point mass? All right. A point mass. Just like heading. For a single what? Point what? Mass. I didn't say point masses. Point what? Mass. Point mass means we only have one mass in that entire what? System. All right. A point mass is a small particle whose entire mass is concentrated. A point mass is a small particle whose entire mass is concentrated at one point, either at one point, located at a distance r from the axis of rotation. Located, you didn't get the definition? From where? A point mass is a small particle whose entire mass is what? Concentrated at one point, right? Located at a distance r. At a distance what? R. Small r. From the axis of rotation. A point mass is also an object, right? A point mass is also an object whose size is so small. A point mass is also an object whose size is so small that we ignore its shape. That we ignore its what? Shape. And treat all its mass as if it is located. Whose size is so small that we ignore its what? Shape. And treat all its mass as if it is located at a single point. At, where are you? Let me repeat again. A point mass is also defined as what? An object, right? Whose size is so small that we ignore its what? Shape and treat all its mass. Either and treat what? All its mass as if it is located at a single point. Let me explain. Then I also explain for multiple particles. Listen, rotation occur at a point called what? Axis of what? Rotation. There's what called axis of what? Rotation. For us to have rotational what? Dynamics, there must be what? An axis of rotation. Please give me one disk there. Axis of rotation is that point in a system where that system rotates from. Like for a disk, are you there? Where is located? At the center, right? If I have a disk, let me get me a disk. Okay. If I have a disk, help me with a pen there. Let's say this is the rod and this is a disk. For me to make this body to rotate, what do we do? I have to insert the rod, right? Inside what? The disk. This is how every fan operates. There's always the rod that passes through the center of a fan that causes the fan to what? To rotate. Are you there now? So this line here, this rod here, which is perpendicular to what? To this disk, is called what? Axis of what? Rotation. Axis of rotation is not the center actually. It is this line that is what? Orthogonal to what? To the disk. Are you there? That forms angle what? 90 degrees. That causes this disk to rotate. That's called axis of what? Rotation. For a body to rotate, there must be what? An axis of what? Rotation. Located at a point in that system. Now, for a single point mass, we said what? What do we say a single point mass? Is an object, right? Whose mass is so what? Is so small, right? That what? That we have to ignore what is shape. Now, listen. If, let's say I want to determine my moment of inertia for a single point mass. Let's say I have a single point mass. Very small. Don't mind this diagram. A point mass is a system whereby we can locate where the mass is. Am I communicating? Like for example, now if I have a ring, who knows the ring? The mass of the ring is where? Is located where? At the edge of what? Of that ring. Abi? I can locate where the mass is. Every object have where their mass is located and concentrated. Hope you are aware. Are you aware? If I have this, between this and this, where is this mass? Where is the mass? Center, right? Is that not somebody? For this body to balance, I have to locate what? The center. Is that not somebody? Then rotate the body, right? So there is always an axis of what? Of rotation. But for a single point mass, a mass that is very small, that we cannot determine where the particle is located. If I have this, let's say I have a big mass. For this, I can find if my particle is here, for instance. Let's say here, I have here to be M1. Here's what? M2. If here's what? M3. And here's what? M what? 4. Let's say here's what? M what? 5. And B. From here to here, here will be what? R1 and B. Here will be what? R2. Here will be what? R3. Here will be what? R4. Here will be what? I will find. Are you getting the concept here? If I have a system with multiple particles, I can easily say, yes, my mass is here, B, my mass is here. But if I have a small body or a small system, to get the entire mass, I have to treat this as what? A single what? Point what? Mass. Then I will assume that the entire mass is where somebody in one particular what location. Or maybe the entire mass is just, let me use this now to explain. There's somebody I cannot place at the center. I can't get their rotation. So what do we do? I have to assume that the entire mass is what? Is this? It's just one. But this kind of system, because it's big, I can determine, I can locate Abi, I can place what? The eyes of our symmetry to know where the object will do what? Rotate. So for a point mass, for what somebody, a point mass, a body whose mass or which size is very what? Small. The inertia of a point mass is given as mr squared. Are you there, somebody? Where m is what, somebody? The mass of what? Of the body. Of what? The body. R represents what? Radius or distance from the what? Axis of what? Rotation, right? To what? To the point, right? Where the body is what? Is concentrated. Is that not? Are you following somebody? Then I represent what, somebody? You know what I represent, right? Inertia. But for a system with what? With multiple what? Particles, Abi? My inertia becomes what? I equals sum of all the inertia. Meaning sum of what, yeah? M, Abi? Mi, RI what? Squared. Which is equals to what here? What the first inertia we have? Here be what? M1 R1 square Abi plus what? For second, what do you have here? M2 R1 2 squared plus what? M3 Abi R3 what here? Squared plus dot 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 M what? Mn Rn what? Squared. Are you getting the concept now? Because for this, I have a bigger body that have I means I have multiple particles here. No, now this already a summation now. Is there already? That's why I have to put I to represent it. Is that clear? Uh-huh. Okay, so it simply means M1 R1 square plus. Put this on, just right. For a system with multiple particles, the body is made up of many small particles. The body is made up of many small particles. Is that not what we say? Right? The body is made up of what? Many what? Small particles. Each particle has its own distance from the axis of rotation. Each particle has its own distance from what? Axis of what? Rotation. Each particle has its own distance from the axis of rotation. Therefore, moment of inertia for a system with multiple particles. Therefore, moment of inertia for a system with multiple what? Particles is given as this. Can put this on the board. Is given as what? As this. Are you there, somebody? Is given as this. Am I communicating? It is given as this. I equals sum. This means summation. Hope you are aware. Summation, Abi. This is summation sign, right? Summation of all the masses times square of all the radius of all the particles away from the axis of what? Rotation. If you are done, let me know. Yes. And that means we have many of them. This means Mn Rn squared. Meaning I can have M4, M5, M6, M7, M8, M100, Abi, depending on how large. Do you get the concept here? Okay. Now, subheading after this. Let me give you something after this. Before we go into definite what? Shapes. Subheading, radius of gyration. Okay, gyration. Gy. Radius of what? Gyration. Now, look at this. Because it is kind of laborious or difficult if I have a larger body and we will start calculating for each of them. Do you get the concept here? What if I have more than 100 particles? Will I keep on doing that? No. Now, instead of doing that, I can compress the entire mass as a single what? Mass. Then compress the entire radius as what? A single radius. That single radius is called what? Radius of what? Gyration. Am I communicating here? Now, radius of gyration, correct me here. Radius of gyration is given as I equals capital M, not this small m, because we are summing all the masses together, right? for a what? System of multiple what? Masses, right? Capital M times what? Capital K, then what here? Squared. Where K represents what here? Radius of what? Am I communicating? What does that imply that I equals to M, abi? K squared equals to what? Sum of these, abi? Sum of what? Of M what? I, R what? I what? Squared. Are you following somebody? Well, I'm compressing the entire mass of a bigger body into what? Is a one single mass, abi, called what? Capital M, abi? And one single rate is called what? Of gyration. That means that the entire value here is equal to what with this? From here, can I make my K square a subject here? How do we do that? Divide both sides by what? By M. This M, abi? That means my K square here becomes what? Sum of all masses, Mi squared, abi? Over what? Over capital M. Don't forget, mass. Then my K becomes what? Square root of what? Sum of all masses, right? Over what here? N. Which is also equal to square root. What do we say this represents? Somebody help me? I, abi? Can we say K is equal to I over what? Somebody? M. Put this down for formula for finding what? Radius of what? Gyration. Where K is called what? Somebody? Radius of what? Gyration. Please put this down. I should explain again. For a system of multiple particles that want to compress that system into a single point mass or into a single mass, instead of calculating for each of them, because we can have a body that has multiple particles, hundreds of them or thousands of them. Do you get the concept here? We can't keep on doing this. M1 plus M1 R1 square plus M2 R2 square plus M3 R3 square plus. Do you get the concept? So what we do is to compress them into a single mass called what? Capital M. Then into the radius into a single radius called what? Radius of what? Gyration. Are you there now? So that means that the whole of this is now equals to what? So I say I equals what? MK square B. I equals MK square equals to what? This. I'm compressing them now. From here, we now make our K as what here? Subject. By dividing both sides by what? By M. Meaning K square equals sum of MI, our I square B. This I, right? Over what? Somebody? Over capital M. Then from here, to get my K, I have to square root what? Both sides, abi? Meaning K equals square root of what? This. And this represents what? I over what? M. That means for any shape, for any what? Shape, to find your radius of gyration, just use a what? Inertia of that shape over what? Somebody? Mass. Are you there, somebody? For any shape. Don't worry, as time goes on, we'll solve more examples. Solve your part. Yes, ask a question. Because the sum here, I is equals to I. I equals sum of M arrow I squared is same as what? Inertia, which is yes. Yes, yes. Because this masses here, they are small particles located in a bigger world body. Hope you are aware. If I have a body, there are some body that, how do we get this now? Look at this board, for instance. Are you there? To rotate this body, I will locate what first? The center. Hope you know that the particles that makes up the entire mass of this body is found around that. Is that not? So how do we start getting the inertia of each of these particles? How do we do that? There's no way we can do that. The only thing we can do is to assume. We take an assumption. We call it a hypothetical assumptions that the entire mass of the system, are you there, is taken as a single what? Mass. Are you there, somebody? Just assume that the entire mass here is taken as what? As a single mass. And it was somebody, capital M, abi? Then the entire radius of each of these particles from the axis of rotation is taken as what? As okay. Am I communicating here? Who is not following? Let me see your hand up. We are all following, right? That means my capital M K square equals what? Sum of what? Mi I what? Squared. For a system that has a multiple what? Particles. Am I communicating? Are you getting the concept? We are assuming that the entire particles, the distance, the entire particle, the masses of those particles is taken as what? As one mass. We are assuming. We can't keep on finding now. We now locate. Can't keep on locating each of the particles in a body. The general figure they use to assume all masses is what? Capital M. Then for the radius is what? Capital what? K. And that K represents what? Radius of what? Gyration. Which is the assumed what? Radius. Is that clear? Is that clear? Oh yeah, let me give you this. Right. Radius of gyration. Let's define. Radius of gyration is the distance from the axis. Is the distance from the axis of rotation is the distance from the axis of rotation at which the whole mass of a body, I said, is the distance from the axis of rotation at which the whole mass of a body can be assumed. Are you seeing the statement now? Can be what? Assumed to be concentrated without changing its moment of inertia. To be concentrated without what? Changing its moment of what? Inertia. Without changing its moment of what? Inertia. Are you following? Do you get the definition now? And let's put this down. Rotational inertia. You know, we're talking about three fundamental inertia of a rigid body, right? What the first one? For a what? For a point mass, abi? Number two is what? Number three is what? Under definite shape is also called common shape. Common what? Shape. Rotational inertia of a definite shape, right? That's the next one, right? Rotational inertia of what? Of definite, right? Shape, right? In brackets, common what? Shape. Okay, this is where I won't be deriving. I will just be listing them. Derivation will take me time, okay? Put this down. We have some common shapes I would like to show us. Are you ready? Number one, moment of inertia for a thin rod, rather. For a thin what? Rod. For a thin rod through the middle of the rod. Through the what? Middle of what? Of the rod. Meaning, middle means center, right? Through the center is given as IC equals M square over 12. Formula. Once you hear the word, find the inertia of a rod through the center of the rod. Formula is for somebody. IC equals what? ML square over what? 12. M represents what there? Mass of what? The rod, abi? What's the L there? Length of the rod. Do you get the concept? All of these have their derivation from the parallel axis theorem. I won't go into that now. I won't go into that. Except for those who are studying physics. Are they here? Anybody physics? We don't have them, abi? So for you, you don't need it. From to derive it will take me time. Should I derive? I need more to know, sir. Which one? The what? IC means center. C means what? Center. Inertia of the rod at the center. Number two, thin rod. The same thin rod, but through one end. Through what? One what? End. Which is IE equals to, I hope they are writing, ML square over what? Over 13. Over 3 rather. Over what? Over 3. Listen, when you hear the word through one end of the rod, meaning that the axis of rotation is assumed to be where? At the end of what? Of the rod. Hope you know what is the rod. Listen, if this is a rod, I can cause this rod to rotate at the center. Meaning I can create my what? Axis of what? Rotation. Is that not? Or I can put a pivot here. Hope you know what the pivot is like a system that causes a body to, move. Do you know what I'm saying? You know what the pivot, right? I can also make the body to be at what? Equilibrium, right? By the use of what? Of a pivot. Is that not somebody? In the pivot, we say clockwise moment equals to what? And the clockwise. Is that not? Meaning that the body can rotate at the center. Is that not somebody? I can also put the pivot at the end to cause the body to rotate at the end. Are you following now? When the body rotates at the center, to find the inertia of that body is simply what? ML square over what? Over 12. Through one end is what? ML square over what? Over 3. Let me ask this question. Between these two, which one has a greater inertia? Over what? 3 now. Division by 12. Division by what? By 3. Which one is greater? This is greater than this, Abi. That means that there is more inertia at the what? At the edge compared to what? Somebody center. Is that making sense? Okay. The third one. Those are missed some of this class. I will try and list. I gave some formulas, Abi. I'll bring out the formulas again that connects linear motion with what? Motion. I hope this class is hope you are getting it right. Number 3, moment of inertia of a solid cylinder or disc or what? Disc through the center. Through the what? To the center. It is given as IC equals, or I, anyone, just use I because we only have one, which is ML square over what? Over 2. Now listen, for a disc or a solid what? Cylinder. A disc has what? Rotation where? At the center, B. Likewise for somebody, a cylinder. But a solid what? Cylinder. The inertia is the same, which is what? ML square over what? Over 2. For that of a disc and that of what? Solid what? Cylinder. The word R represents what? Radius, Abi, of that disc, Abi. Is that not? What's on M here again? Mass of the disc or what? Or the cylinder. Are you following somebody? The fourth one, molecular capital. It's the same, you just know that it's radius. Small r is generally for a point mass. Is that clear? We use small r for what? A point what? Mass. Can we continue? Another way to explain that system of multiple particles is that in each of them we have different point what? Masses. Do you get the concept? Different point masses. What's the point mass? Is R equals to what? M R square B. Meaning here I can have M1 R1 square B. Here what? M2 R2 square B. Just like that. Do you get the concept? So to get the sum of all these systems, what do? I equals to what? Sum of what? Mi Abi Ri square. Is that not? Then we sum up everything, right? Then to compress everything as a single mass, what do we use? Capital M. What's our radius here? K. Do you get the concept now? And assume radius, Abi. And K here is called what? Radius of what? Gyration. I might communicate to somebody. I will solve some problems. Then I will give some prizes. So people who are following, if you're not following, you will not win my money this morning. Are you there? Except you don't need it. Some will say, I don't need it. You don't know that there's this joy you get when you win the money. Or you don't want to get that joy? Solid sphere. A solid sphere is not same as solid sphere through the center. Through the what? Center. It is giving us inertia equals 2 over 5. M what? M R what? Squared. V. Hollow sphere through the center. Through the what? Center. When you hear the word hollow sphere, what does that mean? A good example is what? Hollow sphere. An empty sphere. Example. Okay, hollow sphere through the what? To the center. Is I 2 over 3. M what again? R square. Number 6. Thin hoop. Also a ring. Or just leave this part. All of this don't need it. It's advanced. We'll stop here for the basic one. Let me see if there are other ones I've not given us. Okay, thin cylinder or disc. Okay, thin rod 1 over 12. Okay, 1 over 3. Are you there, guys? Now let me repeat some things that we discussed. Listen, are you ready? Can I hear? Hello. Last week Saturday, I gave you guys some equivalent parameters, Abi, right? Parameters of linear motion and what somebody, linear motion and what somebody, rotational what? Rotational motion, equivalent parameters. Are you there? Now listen, the first one we have is V equals to what? U plus AT, Abi. Am I communicating here? Now what is the equivalent of this for this? What do we call this here? Angular velocity, right? This means final what? Velocity. This means final angular what? Velocity. Which is equal to what? W naught plus what? Alpha what? T. Are you following somebody? Where U represent what? Initial velocity. This represents what? Initial angular what? Velocity. This means what? Angular what? Acceleration. So for the second one, we said V, right? Equals to what? Yeah? Sorry. V square equals to what? U square plus 2AS, right? What would this be? Final angular velocity square, right? Equals to initial angular velocity squared plus 2 alpha what? Angular what? Distance. Abi, we use theta to represent what here? X. Number 3 is what? X equals to what? Ut plus what? AT squared. What will here be? Angular distance, theta, right? Equals to what? U naught T. This is not W here, where? This is called angular what? Initial angular velocity. Plus what? Alpha T squared. Give me all the parameters. Those that came in my class. Give me all the parameters. Force is equal to what? MA, right? Force is under linear, right? We use force. But here we use what? Torque, right? And we say that mass represents what? Inertia. I'll say inertia. Hello. For a linear motion, we apply what? Force. For a body rotating, we apply what? Torque, right? So torque equals inertia times what? Alpha. Are you there? Are you following? This torque is same as FR. Hope you're aware. Are you aware? That torque is same as what? FR. But don't put it here. I will just give it under. Just note. Let me put this down somewhere. That torque is equal to what? Somebody? Just take note first. Numbers torque is also given as torque. Number formula for torque is force times what? Radius. Do you understand? It's not that I got it from here. It's just a normal formula. Yeah. What again do we have? Work done. What is work done? Force times what? Yeah, what is work done? What is our work done here? W equals to what is our force here? Torque, Abi. Torque what? Theta. Or what's my torque here? Inertia alpha what? Theta. Right? What again? Power is what? Work done over what? Time taken, right? Okay, let's go. Meaning the power here becomes what? What's our work done? We can either use torque theta over T, or we use what? Inertia alpha theta over T. Or what? You can tell me. Angular what? Velocity. Do you know why? Angular velocity is what? Somebody. Theta over what? T. Abi? Is theta over T. If theta over T is this, here becomes what? Inertia times alpha. Abi? times what? Angular what? Velocity. What's the next one? You said? Now, theta over t is what? T. So what will it be now? Inertia times alpha times what? Velocity. What's that k here? Let's go. K is what? Half mv squared. Ke, sorry. Ke, right? Is what? What's that ke here? Half inertia angular what? Is also called rotational what? Or say inertia. Energy is also called what? Rotational energy. I need somebody. What's the next one? Momentum. Or say, hey, momentum. Okay, let me go. Continue, right? Momentum is this, Abi, mv, Abi. What momentum for here is L. L equals to what? Inertia velocity. What again? Nothing, Abi. Then I give you some notes, right? Notes. Note the following. What the first note I gave? Work done by a couple, right? Is what? Work done by what? A couple, right? Is W equals to what? 2F arrow what? Theta, right? Where theta is called what? What's theta called? Angle of what? Rotation. Then theta, which is the angle of what? Rotation, is given as what? 2 pi what? N, Abi? Where theta is what? Angle of what? Of rotation. What again? Which is what? I give it, Abi, as what? You know it already now. I equals to what? M_r square. Okay, that was what we said before, right? Inertia is given as what? M_r square. What again? One revolution. This one falls under what? Nothing. Okay, note. Note what? One rev equals to what? 2 pi radian, right? I think I explained this in maths. What again? Note this. Note what again? Angular velocity, which is this, Abi, is what? Theta over what? Change in theta over change in time, which is same as what? Theta over time, Abi, which is what we have here, right? Theta over time, which is angular what? Velocity. What again? Alpha equals to what? Over time. Do you know why we have this? Listen, what is acceleration of the body? Velocity over time, Abi. This becomes what? This is under linear, right? Then when it comes to rotation, it becomes what? Alpha equals to what? Angular velocity over what? Over time, Abi, which is this, right? What again did I give? Relationship between what? A boy and a girl? Okay, linear and what? Okay, I thought it's a boy and a girl. Can I clean here? Can I clean? Yeah, please, right. You left. There are some things you missed, though. I didn't mention them last time, so you collect the notes. A lot we discussed, Abi, before we started again. Because I'll be applying them now to solve some problems. Then we are done with this topic. Hope you still have your questions with you. The one I shared that day. Relationship, right? Between what? Between linear. Between linear and what? Angular what? Angular what? Quantities, Abi. What's the first one I gave you guys there? X equals to what? R what? What's the first one? R what? Theta. Or what? Somebody? Or theta R, Abi? Or we say X equals to what? Theta R. Number 2 is what? V equals to what? R what? Angular velocity, right? Or V equals to what? Angular velocity what? R, right? What the third one here? A equals to what? Somebody? R what? Alpha or what? Alpha what? Or A equals to what? Alpha what? R, right? That is all right. These are the basic, or these are the relationship between linear and angular what? Quantities. Where S represents what here? What's S here? Displacement equals to what? R times what? Angular what? Displacement. What's of V here? Velocity equals to what? R times what? Angular what? Velocity. A equals to what? A is what? Somebody? Which is what? R times angular what? Acceleration. The first question, let's solve from here first. We'll go into that booklet. A uniform disc of mass 20 kilogram. A uniform disc of mass what? 20 what? Kilogram. And radius 0.15 meter. A uniform disc of mass 20 kilogram. And radius 0.15 what? Meter. Is mounted on a horizontal axle. 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 How do you pronounce this? Axle, right? Okay. Calculate each moment of inertia. Calculate what? Each moment of what? Inertia. Can I explain this? Huh? Mass is what? 20 kilogram, right? Read now. What's the radius there? 0.15 what? Meter, right? It's mounted 0.15, okay? 15 what? Meter. It's mounted on what? As of what? Moment of inertia. Okay, solution to this. This is very simple. We are told that is what's the body there? Is it a disc or a cylinder? A uniform disc, Abi? What do we say is the moment of inertia of a uniform disc? Moment of inertia of a uniform disc is what? Of inertia for a disc, Abi, is what? I equals to what? M square over what? Over 2, Abi? Huh? For a disc, can put D here if you want. So that means inertia of a disc becomes what? Let's go. 20 times. What's my radius here? 0.15, Abi? All square over what? 2. Are you seeing how simple this can be, right? So 2 here, 1, 2 years what? 10, Abi? Here becomes what? 10 times. 0.15 square is what? 0.15 square is what? 0.0225. Multiply this by 10. What do you have? What will it be? 0.22 what? 5. Are you there? Inertia, general expression is what? M square, Abi? Meaning, what's the unit of inertia? What will it be? Mass is in what? Kilogram, right? What of radius? Meter. So meter square, right? What will it be? Kilogram meter what? Squared. Am I communicating here? Kilogram meter what? Squared. Kilogram meter squared. Hope this is simple, right? Is it simple? That means all you need to know is to know what? The formula for the shape. And I gave us the basic shape we should know. There are many of the shapes, but for your exam, just take note of the ones I gave. Are you following somebody? Okay, put this question down. Are you ready? If the force is 20 Newton, question 2. If the force is 20 Newton, if the force is 20 Newton, comma, radius of the wheel is 4 centimeter. If the force is 20 Newton, comma, radius of the wheel, WHEEL, right, is what? 4 centimeter. In brackets, 0.04 meter. 0.04 meter. Close the brackets. What does that mean? They have converted already. So no need of converting there, right? Okay. 0.0 what? 4 meter. And the wheel makes 5 revolutions. And the wheel makes what? 5 what? Revolutions. Calculate the work done by the couple. Calculate the work done by the couple. Did you capture the question? I should repeat again. Oh yeah, capture it now, right? If the force is 20 Newton, radius of the wheel is 4 centimeter, in brackets 0.04 what? Meter, right? And the wheel makes 5 what? Revolutions. Are you there? Calculate the work done by the what? Couple. Let's bring out the parameters we have there. Let's bring them out. What do you have in the question? Read from the one to go. If the force is what? 20 what? Newton. What's the radius? 0.04 meter, right? Meaning my n is what? 5 what? Revolutions, Abi. Work done by the couple, right? What's the work done by the couple? Formula is what? Work done by couple is what? W equals what? So it's there, right? Good. 2 what? FR what? Theta. Where theta is what? 2 pi what? N. From this question, we have force, Abi. We have force, right? We have R, right? But we don't have what? The angle of revolution. But we are told that theta is what? 2 pi N. Can I get this first? Meaning my theta becomes what here? 2 pi times what? Let us put the value, right? Times 3.142 times 5. What do you have here? Huh? 31 point what? 42. Are you sure of this? 42. Now let's go. Radian. Now let's go. So here my work done becomes what here? Let's go. What will it be? 2 times. What's my force here? 20 times. What's our radius here? 0.04 times. What's the angle of rotation? 31 point what? 42. Multiply them. What do you have? 50.272. In what? Somebody? In joules. Please put this down. Final answer. Where did we stop here? Number 5, right? Hope you have this with you. Okay, let's continue. A string is wound round the rim of a uniform disc that is pivoted to rotate without friction about a fixed axis through its center. Then the mass of the disc is 3 kilograms and the radius is 25 centimeters. The string is pulled with a force of magnitude 10 Newton. If the disc was initially at rest, what is its angular velocity afterwards? 5 seconds. Now let's solve together. Read the equation for me. Then we'll bring out a string. Read now. Uh-huh. Uh-huh. Mass of this is what? 3 kilograms. Radius is what? 25 cm. Uh-huh. The force is what? 10 Newton, Abi. Uh-huh. Uh-huh. Our time is what? 5 seconds. We are looking for final angular what? Velocity. The disc was initially at rest. When the ball is at rest, what happened? Initial what? Velocity is what? 0, Abi. But here we are considering what? Initial angular what? Velocity. Is that not? That means that my initial angular velocity is what? 0, Abi. I'm looking for what? Final what? Angular what? Velocity. Is that clear? Hope you are following. Then our time is what? 5 seconds. Are you there, somebody? So we are asked to find, look at this, recall. To find this, recall that angular velocity equals to what? W naught Abi plus what? Alpha what? Alpha t. I'm looking for this, right? This already was 0. Do we have this? Do you get the concept? I don't have this, but I have what? Time. So let's look for a means to generate what? Angular what? Acceleration. Angular what? Acceleration. Am I communicating here? Now listen. But before that, we are dealing with what? A disc. The first thing I have to do is to find the inertia of what? Of that disc. Of what? Of that disc. Because the disc was caused to rotate. That means the disc possesses what? An inertia. Are you following somebody? Now, inertia of a disc. Recall the inertia of a disc is giving us what? Formula is what? Maybe R square, right? Over what? 2. Here, our radius of the disc is 25 centimeters, which is 25 over 100. Convert, what do you have here? 0. What? 0.25. Okay, 25 what? Meter. So this means radius of the disc, Abi, over what? 2. What's the mass of the disc here? 3. This radius here corresponds to what? That of what? The disc, Abi, which is what? Somebody? 0. What? 25. All what here? Squared. Over what? Over 2. So inertia of the disk becomes what? Let's go. What do you have? 0.0938. Are you sure? Kilogram, abi? Meter what? Meter square. Now listen. Are you also aware that I gave some formulas, some relationship between linear and what? And rotational motion, right? Are you following? Since I have the force here, we are told that force is what? 10 Newton. Are you there? What is the equivalent parameter for force? Is what? Torque, abi? You are aware that torque is equal to what? If force is equal to ma, what's my force? It becomes torque, abi? Equals to what? Inertia times what? Angular velocity. Hope you are aware. Are you aware? Angular acceleration. Huh? So let's go. Here becomes what? Let's go. What will it be? Inertia, be angular acceleration. This also equals to what? Equals to what? Fr. Are you aware that normal formula for torque is what? Force times what? Radius. I gave this, abi. Normal is Fr. Are you there, somebody? Apart from torque being inertia times what? Angular acceleration, it also equals to what? Fr. Don't forget that all I'm looking for is what? Angular acceleration. Is it not? That means to find my angular acceleration, I'll look for what first? My torque. And what's that torque? Force times what? Radius. Do we have force here? Where's our force here? What's our radius? 0.25. Then when you get your torque, I can then find what? Angular acceleration. Meaning torque over what? Inertia. You didn't get it. If torque is Fr, and that same torque is what? I what? Alpha, B. I can solve for torque here. I have force, I have a radius, abi. When you get the value of your torque, can't you get to alpha from here? Alpha becomes what? Torque, abi, over what? Inertia. That torque calculated from here over your what? Somebody. Inertia. What's inertia? 0.0938. Can we proceed? So using torque equals Fr. That will give us what? Let's go. What's our force? 10. 0.25. So torque becomes what? 2.5, abi? 2.5. Okay. The unit of torque here is what? What will it be? Inertia is what? I guess it's kilogram, abi? Meter square. What about angular acceleration? Radian per what? Second, abi? Is that not? Or we can just say from here, what's our force? Newton, abi? Newton what? Meter. Is that okay? Okay. Now, if torque is 2.5, then recall also that what? That torque is what, somebody? Inertia times alpha, right? So alpha or angular acceleration becomes what? Torque over what? Inertia. Let's go. What would this be? 2.5, abi? Over what? 0.0938. So angular acceleration becomes what, yeah? 26 point what? Point what? 65. Okay, let's say 65, right? In radian per what? Per second. Are we done with that? Then recall now that angular velocity equals to initial, abi, plus what? Alpha t. Since the body is at rest, this becomes what? 0. At rest, abi? For a body at rest, this is 0. Here becomes what? Let's go. 0 plus what? What's the angular acceleration? 26 point what? 65 times what? Somebody? What's that time there? 5. So what would this be? Give me the value. 133 point something, right? 133 point what? 35. Are you sure? 25. In what? Somebody? What the unit of this? Or meter per second? Radian per what? Second. Alpha is what? Radian per second square. Sorry. Alpha is what? Radian per second square. It's like saying acceleration abi. We use what here? Squared. But for this we use what? Just ordinary what? Radian per what? Second. Is that clear, somebody? Final answer is this. Okay, next question says, are you ready? Let me read out this so we can resolve, okay? A disc of mass 20 kilogram, radius 0.15 meter, rotates at 26 radian per second, right? How much time is required to bring it to rest if a braking force of 1 Newton is applied tangentially to its rim? Are you there, somebody? Now we are told the mass of the disc is what? 20 kilogram. What the radius of the disc giving? They give us capital R, right? As the radius. What do you have there? 0.15 meter, right? What the force applied? 1 Newton. What again was given to us? Initial angular velocity is what? 26 rad per watt per second. Is that not? Is that not? Now we have to find what? Time. Almost the same thing we solved with the first one. But here we are looking for what? Time. Are you there? For a body to come to rest, when you apply a braking force of 1 Newton, mean the body will have to decelerate. Are you there, somebody? Are you there? It must what? Decelerate. And for the body to come to rest, our final angular velocity is what? 0. Coming to rest. Are you there? So recall the angular velocity is what? W naught plus what? Alpha T. We have this, right? We have this. Do we have this? No. Do we have this? No. I'm looking for this, right? But recall that what? That torque, right? Equals to what? I alpha, or torque equals to what? FR. So what we do is to find torque, abi? What's that torque here? What's that force? 1 times, what's that radius here? 0.15. Here we are using capital R, right? Okay. And what's the value here? 0.15 watts. What the unit of this torque? Newton what? Meter. Are you there, somebody? Are you there? What's the next now? Is to find angular what? Acceleration, right? Recall that same torque is equals to what? You see in inertia. Inertia, right? Okay, I will not even find inertia, right? Let's find inertia of the disc, right? Inertia of the disc is simply what? Let's go. mr squared over what? Over 2. Inertia becomes what? Let's go. What's the mass? 20 times what? 0.15 all squared. Sorry, not all squared. Abi squared here over what? Over 2. 2 here 1, 2 years what? 10. Abi multiply 10. What is 0.15 squared? What do you have? Times 10. What do you have? 0.225. Abi kilogram meter square. So inertia becomes what? 0.225 kilogram meter square, right? Okay. So let's find our angular what? Angular what? Acceleration, right? Please, the order. What's the order? The order is that we have to find what first? Inertia, right? Then after this, you find what? Your torque. Are you there? So please, I jumped the order. Correct this in your notes. For those that didn't get it. Solve what first? Inertia. Followed by what? By your torque. Are you there? Okay, so what do we do? Is to find angular what? Acceleration. Recall that torque is what? Inertia times what? Angular acceleration. So our alpha becomes what? Torque over what? Inertia. What's that torque? 0. What? 15. What's our inertia? 225. Abi? So what's my alpha here? 667. Okay. Radian, Abi? Per what? Second square, right? Recall that angular velocity equals what? W naught plus what? Alpha t. Here becomes what? 0, Abi? Body comes to rest. Then for the body to come to rest, that means the body must decelerate. Hope you are aware. Are you there, somebody? For if you apply a braking force of 1 Newton to stop a body, the body must have to decelerate until it comes to rest. That means here becomes W naught minus what? Alpha T. Am I communicating? Are you there, somebody? So let's go. Here becomes, what is that W naught? What do you have as angular velocity? Inertia 26 AB minus 0. What? 66 what? 70 AB. Are you there, somebody? Can we say this is the same as 0.6670 equals to 26? Huh? When you move this to the other side, becomes what? Plus, right? So how do we find our time? 26 over what? 667. And what do you have there? 20 what? 38 point what? 98 what? 05. I can approximate this to what? 39. 39 what? Seconds. You can do what, somebody? You can second. 39 seconds. I'm not picking this answer. That is good. You are trying. Ibaliala, eh? Ibaliala. Next question. Which money? Did I promise any money? So all of you, I will not give you your money. You don't even know the price I want to give you. The price is thank you for solving. So that is the price. Thank you for solving it. Thank you. Hope you solve. Thank you too. Thank you. Okay, everybody. Thank you for solving. Hey, shake gun, eh? That is our reward. Are you there, somebody? Wow, we are moving very fast. Let's continue. Number 6. Correctly? Are you writing this? I thought you all solved this now. Okay, on a rough. You don't believe in what you solve. A body on circular orbit, makes an angular displacement. Makes an angular displacement, theta t, equals to 3t squared plus 6t plus what? 5, all in radian. Calculate the angular velocity, and angular acceleration at t equals to 2 seconds. Now listen, I've taught this before here, but not on this kind of example. We have learned what we call calculus here, right? A little bit of calculus. Is that not? Can you remember that? Under linear kinematics. You have forgotten. I've told you how to how to differentiate and what? Integrate. Abi, a function, right? But let me take you back. Let me just explain a little bit. Then I will pay attention. Listen, in linear kinematics, we studied some parameters like what? Displacement, Abi. Displacement. What again? We studied what? Velocity, Abi. What again? Acceleration, right? These are some parameters we mentioned. Is that not? Also mention what? Speed, Abi. Are you there? And I differentiated this. I give a detailed note on this. Listen. We say that velocity, we know, is given as what? Displacement, right? Over what? Over what? Time. Am I communicating? Meaning S, Abi, over what? T. That means that when you differentiate displacement with respect to time, you have what? Velocity. Or I can say that a graph of displacement against what? Time equals what? Somebody? Velocity. Am I communicating? If I have y equals to mx plus c, this is a linear graph, Abi. This is a graph of what? Y. against what? X. This is a graph like this, right? That has an intercept, what? C. We call here what? Slope, Abi? This means change in Y over change in what? X. Are you there? The word slope also means the word what? Different what? Differentiation. Different what? Differentiation. Differentiation is just a simple way of finding slope without plotting what? A graph. If I'm to find this slope, I have to plot a graph, Abi? Find my change in Y and change in what? In X. Is that not somebody? For under differentiation, I don't need to plot any graph. I will just use the equation given to find what? The slope. Are you getting the concept here? Now listen. Listen. So for a graph like this, Y equals to mx, we agree that this graph will start from where? The origin, Abi? Because there is no C here, Abi? C means what? The intercept. If I have a graph like this, the quantity, this is a graph, Abi? What point is here? Point C. If here is minus, this graph will be in what form? Downward, Abi? Cutting negative what here? Y. C means intercept on the Y axis. If here is plus, it means positive what? Y. Abi? Here's what? Minus means what? Negative what? Y. But if there's no C, it means the graph is like this. Abi? It is on this basis this falls in. A graph of Y against X, what's the slope? M. Am I communicating here? That means that if I have Y over what? X, what do you have here? Is M. So when you differentiate Y with respect to X, what do you have? We call it the Y, the what? The X. And what does M represent? Slope. Am I communicating? Please take note that for every displacement time graph, what's the slope here? Velocity. Meaning change in what? X over change in what? T. If I have acceleration, what acceleration? Velocity B over what? Over what? Time. This means V B over what? Yeah? Over T. Meaning that change in velocity over change in what? Time will give us what? Acceleration. That means for every velocity what? Time graph, what's the slope of that graph? Acceleration. Am I communicating? Are you following somebody? Does this mean V2 minus V1 over what? Somebody? T2 minus what? T1. Abi? Change means final minus what? Initial. Over what? Final time minus what? Initial time. What about this? This means what? S2 minus what? S1. Over what? Somebody? T2 over what? T1. Hope you are aware, somebody? Now, let me take us through another journey called differentiation. Called what? Differentiation. Differentiation is a simple way of finding slope or gradient without plotting what? A graph. That's how I can explain it. If I'm to differentiate, we have to methods of what? Methods of what? Of differentiation. Of what? Differentiation. Number one is called the general method. The general what? Method. We have other methods and we'll not list them. Are you there, somebody? This for second what? Semester. Are you there? All throughout your second semester, throughout, you must keep on differentiating and what? Integrating. It's purely calculus. Purely what? Calculus. Are you there, somebody? But let me show you the general method. All you need to solve this is what? General what? Method. If I have Y equals AX raised power what? N. Raised power what? N. The general rule of this means what? The Y, the what? The X. Meaning change in Y over change in what? X is equal to, the rule says, multiply this power here, this exponent, by the what? By this A here. Or by the coefficient of what? Of X, and which is what? A. And subtract what? 1 from that power. Meaning N times A is what? Is NA. B. What do you have here? X raised power what? N minus 1. For example, if I have Y equals to 2x raised power 4, what does this imply? The Y dx is equals to what? What is 4 times 2? 8x raised power what? 4 minus 1 B, which is what? Somebody? 8x raised power what? 3. Am I communicating? Now listen. Pay attention. I'm not cleaning, don't worry. Say not cleaning. I'm not cleaning. Now listen. Now let's say we have displacement equals to 2t raised power 3. And I say differentiate this. If I have y equals to 2x, y is a function of what? Of x, abi? Yeah, s is a function of what? Of t. Am I communicating? Differentiating is between two variables, either x or y, either x or any other thing. Are you there? So for this now, differentiating y with respect to x, you know what happened here, right? Meaning this, to differentiate, what will I do? It means what? The x over what? The t. The what? Somebody? The t. This means the y over what? The x. This means the x over what? The t. Or look at this thing here. Is equal to what? The general rule is what? 3 times 2 is what? 6 what? T raised power what? 2. Are you there, somebody? What do we call displacement over time? What do we call S over T? Is that acceleration of velocity? What is velocity now? Displacement over time. What acceleration now? Velocity over time. Maybe meaning that after differentiating displacement over time, what do you have here? Velocity. That means that my velocity at any time t is equal to what? 60 squared, or in what? Meter per what? Second. Are you getting it now? They might tell you to further find what? Acceleration. Say find what? Yeah? Acceleration. Find what? Acceleration. What is acceleration? Velocity over what? TRB. Meaning I will differentiate what again? Velocity with respect to what? Time. This is my what? Velocity, abi. To find acceleration, what do you have here? Here becomes what? The V, abi, over what? The T. And that will give us what? Let's go. Let's go. 2 times 6 is what? 12t raised power what? What is 2 minus 1? Say is 1, abi. What do we call this? In meter per second was squared. This is very simple. Am I communicating? Let me give another example. Clear here now. Which side? This, abi. Please watch. Listen now. Listen. Listen. Stop writing and pay attention. This is a building skill in calculus. I'm giving you a building skill. Listen. Listen. If you are giving this now, let's say you are giving xt equals 6t squared plus, let me use 6t cubed plus 5t squared plus 7t. Find number 1 velocity at t equals to 2 seconds. Are you there? Number 2, find what? Acceleration at what? T equals to what? 2 seconds. Pay attention and listen. How do we find velocity if displacement is given? What do we do? I will differentiate, abi. I will do what? Differentiate. Meaning to find my velocity. What do we say the formula? The what? Somebody. The x over what? The t. What's the answer here? 3 times 6 is what? 18 what? T squared, abi. Plus 5 times 2 is what? 10t, abi. Here we have 1, abi. What is 7 times t, yeah? Plus 7. Because the power of t here is what? Is 1. When you subtract 1 from 1, what do you have? 0, abi. And what t raised power 0? 1. If you differentiate 70, you have what? 7. Differentiate 80, you have what? 8. Differentiate 100t, what do you have? 100. If you differentiate 100, what do you have? 0. Differentiate 7, what do you have? 0. Differentiate 8, what do you have? 0. That means anytime you differentiate any constant value, the answer is what? 0. But we are told to find what? Velocity at t equal to what? 2 seconds. Meaning after differentiating this, so this is vt, abi, equal to this, right? Meaning v what now? 2 equals to, anywhere I see t, I will now put what? 2 seconds. That will give us what here? 18 times 2, all what? Squared, abi, plus what? 10 times 2 plus what? 7. What is 2 squared? 4 times 18 is what? 70, 70 what? Are you sure of this? Plus what, yeah? 20 plus what? 7. What's the total answer? 90 what? 9 meter per what? Second. Are you there? Okay. Then, what if they say find acceleration? What will you do? I will now differentiate what? My VTRB, meaning what? Yeah, will be what? You know what to do, right? Oh yeah, right. Just put down some things there. Can I solve for acceleration? What acceleration? This is a building scalar B. What is acceleration? Change in V over what? Change in what? TRB. What will this be? How do we find change in T here? In V rather. I will differentiate VTRB. Meaning 2 times 18 is what? 36 what? T. Differentiate 10 T, what do you have? 10. Differentiate 7, what do you have? 0. Hope you are aware. Because 7 is a constant. There's no T here. Just take it as what? 0. So what will be the result here? Plus what? Plus 10. Are you there? So A becomes what? 36 times. What's my T here? 2 Abi? Plus what here? 10. 2 times 36 is what? 70 what? Plus what? 10. What's the answer? 82 meter per what? Second squared. Are you seeing how simple this is? Where's our ink? Okay, no problem. Ew. Collect me now. Collect me the middle part. Now listen, notes. Please tell me this. Hello? If X represents displacement, Abi, eh? Under what? Linear motion, right? Are you there? That means, what is the equivalent parameter to this in rotational motion? If X represents displacement, is that not somebody? What is the equivalent parameter to this X in, is what somebody? Theta. Abi, theta is what? Angular what? Somebody? Angular what? Displacement. Hope you are aware. If V represents what? Final what? Velocity, right? What is the equivalent parameter to this? Angular what? Velocity, right? Which is what? Angular velocity. Hope you are aware. If you represent what? Initial, right? Initial what? Velocity. What is the equivalent parameter to this? W naught, right? Is what? Somebody? Initial what? Initial angular what? Angular velocity. What about if A is what? Acceleration. What will it be for rotational? Alpha. This means what? Angular what? Acceleration. Now listen. Collect me here. Collect me here. Okay, the other side. Collect me here. Please pay attention. Let me just divide into two. Listen. If I have linear here and I have what here? Rotational, What do you say is our VT? What's our VT? V is, how do you find velocity? Displacement over what? TRB, right? Meaning change in what? X over change in what? Hope you are aware. Are you aware? What would this parameter becomes? WTRB equals to what? Change in what? Theta over what? Change in time. Am I communicating? For that of acceleration, if AT is equal to what? Yeah, let's go. VT, abi, over what? Over time, right? Or we say V over what? T. V over what? T, abi? Meaning changing what? V over changing what? T. What of this becomes here? Alpha was somebody. T, equals to what? D what? W, abi, angular velocity over what? Somebody? Dt. Now listen. A body on circular orbit makes an angular what? Displacement. Meaning we are giving what? Angular what here? Displacement. As what? 3t squared plus 6t plus 5 in what? Radian. Calculate what? The angular what? Velocity. And angular what? Acceleration. How do you get angular velocity? What's angular velocity? Where is it again? Differentiate what? Your angular what? Displacement with respect to what? T. It means I will differentiate this, abi, and put my t as what? 2 seconds. That will give us what? Angular what? Velocity. Am I communicating? That means to find my angular acceleration. What do we do? Differentiate your angular what? Velocity with respect to what? Your time. Can we do that together? Can I clear now? Of course, yes. What are you writing since? Are you painting your notes? Yeah, let's watch. Listen, we are given the angular displacement at any time t is equals to what there? 3 what? Square plus what? 6t plus what? 5. All in radian. To find angular velocity, angular velocity, meaning what there? What does that mean? Wt, right, is equals to what? Just recall, right? Recall that this is equals to what there? The theta over what? The t, which is equals to what? Let's go. Let's differentiate, abi. Differentiate, what do you have here? What is 2 times 3? 6t plus what? Plus what? Plus 6. Plus 0. That means plus 6, abi. But we are given that. But t equals to what? 2 seconds. That means my W2, abi, becomes what, yeah? Becomes what, yeah? Let's go. 6 times 2 plus what? 6. What is 6 times 2? 12 plus 6 is what? What is the answer here? 18 rad per what? Per second. Is that not simple? You saw how we started from linear into what? Rotational. The same thing. Eh? The next question. Can I play here? You already know all these things now. You know them now. Are you still repeating them again? This is just a teaching aid. I'm just teaching. Now listen. Number 2 says what? Find what? The angular what now? Acceleration. Meaning find alpha. And what's the alpha? Change in what? Angular velocity, right? Over change in what? Time. What would this be? Look at this. Recall that our angular velocity at any time t is what? What do you have? 60, abi? 60 plus what? 6. Huh? Now to find alpha, means I will differentiate this, abi. What would this be? Alpha becomes what? Differentiate. 1 times 6 is what here? This is 6, abi? Plus what? 0. What's my alpha here? 6. 6 rad per what? Second. In this case here, there's no space to start putting t as what? 2 seconds. Do you get the concept? Because t has disappeared. So I'll take it as what? 6 rad per what? Per second. Eh? That means that at any time, even if the time is 4 or 5 or 20, it's still what? 6. Eh? Okay, put it up. Yes. Yes, radian per second square. Thank you. What's the next question? Number 7, right? Number 7 says, what is rotational what? Inertia, right? Number 7 says what? What is rotational inertia? Is in your notes? Okay. What's the next question there? A disc of mass 5 kilogram with a radius of 1.3 meter is spinning at an angular what? Velocity of 15 rad per watt. Angular speed, yeah, they are the same, of 15 rad per watt second. What is the inertia of the solid disc, right? Okay. The mass there is what? 3 kilogram, right? Oh, sorry, 5 kilogram. Mass is 5 kilogram. What is happening? I have shared this in even before Saturday. Oh yeah, let me detect again. A disc of mass 5 kilogram eh, is spinning. So a disc of mass 5 kilogram with a radius of 1.3 meter is spinning at an angular speed of spin at an angular speed of what? 15 rad per second. Angular speed of 15 radian per what? Second. Are you there? What is the inertia of the solid disc? You can even solve this for me. Formula is what? Over 2. Yes, can you solve that? Although we are given angular what? Speed. You don't need it. Angular speed is only used to find maybe energy or moment or maybe, do you know what I'm saying? What is the angular what? What is the inertia of the solid disc? Radius there is 1.3 meter. Solve. What's the answer there? I won't solve this for you. Eh? Correct. Mass is 5 kilogram. Radius is what? 1.3 meter, right? And we are told that angular velocity is what there? 15 rad per what? Per second. Are you there? Inertia of the disc, right, is what? mr square, right? Over what? Over 2. So inertia of the disc becomes what? What's our mass here? 5 times. What's our radius? 1.3 all squared. Over what? 2. What total answer here? Give me the answer. 4.225, abi? Kilogram, meter what? Meter square, right? Very simple. Someone will ask, why are we not using angular velocity? Because I'm not finding energy or anything. Are you there, somebody? What did they say? Find the rotational energy. Add it to the equation. Find the rotational energy of the disc. Add it. Are you there? Rotational energy of the disc will be what? Energy, abi, is what? Half what? I W square. Is that not? Where I represent what? Inertia of that disc, abi? Can we solve it now? So my energy here becomes what? Let's go. Half times, what's the inertia? 4.225, right? Times what? What's angular velocity? 15. Sorry, 15. All what? All squared. So energy becomes half times 4.225. What's 15 squared? 22 what? 5, abi? Multiply 225 by 4.225. Then divide by 2. What do you have? 475 point what? 315. 3125. Okay. Joules, abi? Do you understand the concept here? I just added another question. Divide number 1000. So to kilojoule, you multiply, right? By 1000. Why are you converting it? So, okay. Multiply by 1000. Okay, it was even there, sir. Then I no, it's a mistake, not number 9. It should be what is the what? Rotational what? Kinetic energy of the disc. Are you there? That is number 8. It should be 8B or something, right? 8B, right? Not 9 or 8A. What is what? Rotational kinetic energy of the disc. Which is this, right? Are you following? The next one is prove that rotational what? KERB is equals to what? Half inertia angular velocity what? Squared. Can we prove? We're almost done. Hope you are following, right? Hope you are following. Which side? Prove that what? Prove that what? Energy abi is what? Half what? Inertia, angular velocity square abi. Okay. Solution. This is very simple. Listen. From energy or KE. What's that KE? K is what? Half what? MV what? MV square. Right? Please pay attention. I give you guys a relationship between velocity and angular what? Angular velocity, right? V equals to what? WR. Am I correct? Is it your notes? Is it your notes? If this is equation 1, this is what? Equation 2. So I'll say put, Abby, put equation what? 2 into what? Equation what? 1. Meaning I'm putting the value of my V as this V here, right? Huh? That will give us what? Energy equals to what? Yeah? Half what? M in bracket, right? What's my V here? WR, right? All what? All squared. Am I communicating? So energy becomes what here? Half M. Can we expand this? What will here be? W square R squared. Are you there? I can also rearrange this to be what? Energy equals to what? Half abi M R squared times what? Angular velocity was squared. Abi? Recall that inertia of a point mass. Are you following at all? Point mass is what? Mass R squared, abi? Is that not? Can I replace this here with I? If I should replace that, what would be the final answer there? Let's call this equation what? 3, abi? This equation what? 4, eh? So I'm going to say put what? Somebody? Equation 4, right? 4 into what? Equation what? 3. Meaning anywhere we say I, we say mr square, I'll put I, abi? That implies that my energy becomes what? Half I, abi? W square. Is it easy to find? Are you sure it's easy? Or should I repeat it again? It's easy, right? Just know this relationship that E equals what? Half mv square. V equals what? WR. I gave this formula. If V equals WR, that means I can replace my V here as what? WR. So we say put equation 2 into equation what? 1. Meaning anywhere I see this V, I'll put what? WR. Here becomes E equals half M. What's my V? WR all squared. Abi? I can expand this. Here becomes what? Half M. W square R square. Rearrange this. This becomes half M R square W square. Note that M R square represents what? Inertia of a point what? Mass. Which is what? I equals what? M R square. Abi? Then we will now replace this as what? As I. Then E becomes what? Half I. Abi? W what? Squared. Very simple. Can we solve now? Are you ready? A disk of rotational inertia 10 kilogram meter squared. 10 kilogram meter what? Squared. Rotates, 10 kilogram meter squared, right? About its center. I repeat, a disk of rotational inertia 10 kilogram meter squared about its what? Center. Rotates with an angular velocity of 20 radian per second. Rotates with an angular what? Velocity of 20 radian per what? Seconds. Calculate number 1. Its rotational what? Energy. Number 2. 1 is what? Rotational what? Energy. Number 2. Angular momentum. Number 3. Number of revolution the disk makes per seconds. No. Number 1. Rotational energy. Number 2. Angular momentum. Number 3. The number of revolution the disk makes per what? Seconds. Very simple. If this should ever appear in your exam, just be smiling. I need somebody. Number of revolution the disk makes per second. Eh? Can you solve this for me? Attempt this question. Let me pause my video. Attempt, all of you. Okay, let's solve the question together, right? Are you following? Are you following? Question says what there? A uniform disk of what? Mass 3 kilogram. A uniform disk. Let me read. What the question? A uniform disk of mass 3 kilogram and radius 12 centimeter rotates at 480 revolution per minute. Are you there? Find its what? Kinetic what? Energy. The mass of the disk is what? 3 kg. Are you there? What's the radius there? 12 centimeter, right? Which is equals to what? 12 over 100, right? Convert to meter. What do you have? 0.12 what? Meter. Are you there? Then we are told that it rotates at what frequency? Frequency there is what? 480 abi? Revolution per what? Per minute. So what do we do to convert this to what? To per seconds, abi? Meaning that this is also same as 480 revolution over what? 1 what? Minute, abi? Are you following somebody? Huh? Divide means over 1 minute. And what's 1 minute? 60 seconds. So I can replace it with what? So 1 minute is equal to what? 60 what? Seconds, abi? So that my frequency becomes what, yeah? 480 revolution over what? 60 seconds. Eh? So divide 480 by 60. What do you have? We have 8 revolution per what? A second. But to find the rotational energy, abi, I will need angular what? Velocity. Because energy is what? Is what? Half what? Inertia angular what? Velocity, right? So let's find our angular velocity, which is what? Somebody? 2 pi f. And that will give us what? 2 times 3.142 times, what's our f, yeah? 8. So what do you have as angular velocity? 50 point what? 272, right? Radian per what? Second square, right? Hope you're aware. Then recall, let's find inertia of the disk. We need inertia, right? Inertia of the disk is equals to what? Half what? ml square, right? Which is same as what? Half times what's the mass? What's the mass of the disk? 3. What's the radius of the disk? 0.12, all what, yeah? Squared. So inertia of the disk becomes what? Half times what? 3 times 0.12 square is what? 0.12 square is what? 0.0144. Multiply this by 3, divide by 2. What is the total inertia? 0.0216, right? Kilogram what? Meter square. Thank you. Now, what are we looking for? Is what? Kinetic energy, abi, which is same as what? The rotational what? Energy, abi? Rotational what? Energy. Are you following somebody? Energy. Huh? And that is what's our formula there? We can say KE, right? Is what? Half what? Inertia, angular velocity what? Yeah? Squared. So our KE becomes what? Half what? What's the inertia? 0.0216 times, what's the angular velocity? 50.272, all what? All squared, right? So our KE becomes what, yeah? Half times 0.0216 times 50.272 squared is what? 2527.274. Are you sure? Multiply this value with this, then divide by 2. What do you have as the kinetic energy there? 27 point what? 2946 joules, abi? We can also approximate this to be what? Our Ka equals to what? 27 point what? 0.3 what? Joules. Very simple, right? Right? Where? Sorry, please. This is rad per what? Second, not per second square. Okay? Are you there? Angular acceleration is what? Rad per second square. What angular velocity? Rad per what? Second. Please take notes. Don't forget. So this should be rad per second. Let's look at this question. There we go. Calculate the radius of gyration for a solid sphere. Calculate the radius of gyration for a solid what? Sphere. Are you there? Of diameter 10 centimeter. Of diameter 10 centimeter. Calculate the radius of gyration. Hope you know how to spell that. We learned at this point now of what? Gyration, right? Which is key, right? Huh? For a solid what? Sphere. For a solid what? Sphere. Of diameter 10 centimeter. Of diameter 10 what? Centimeter. And with its rotational inertia. And with its rotational inertia. And with its rotational what? Inertia. As I equals 2/5 m what? R square. And with its rotational inertia as what? 2/5 m what? M R square. Now listen. You know we say for a single point mass, the inertia of the body is what? I equals to what? M R square. B. Are you there, somebody? For a point mass, inertia is what? M R square. But for a system of particle, right? Of what? Particle, multiple particles. Is that not somebody? Inertia is given as what? Summation of what? R equals to what? Sum of what? Mi r I square, right? Which is equals to what here? M1 r1 square plus what? M2 r2 square plus what? Mn rn what? Square B. Are you there? Now we can have a very large body. We can't keep on finding the individual what? Inertia. Are you there? We can sum the entire mass as a single mass called what? Capital what? Somebody? M. Abi? Then sum the entire radius as what? As what? Somebody? K. Then we have what? The square. Are you there, somebody? For a large body, where we have small mass, like I have a board now. Are you there? In this board, we have every of these points here have their various words. Mass, Abi? Are you there? We cannot keep on finding their inertia. What we do is to sum that the entire mass of this body as what? Capital M. Then the entire radius as what? K. Where K is called radius of what? Gyration. Are you there? Now, radius of gyration, if I'm to sum this, that implies that the sum of what? Of my M1, Abi, Mi RI square is equal to what? Somebody? Capital M, Abi, K what? K squared. Don't forget. From here, can I make my K a subject here? Here, K becomes what? K becomes what? K square becomes what, rather? Sum of what? Mi RI square over what? Capital M. Is that not? So my K becomes what here? Let's go. Square root of what? Sum of what? Mi RI squared over what? Over M. This is same as what? Inertia, Abi, equals to square root of what? What do we call this here? Inertia, Abi. So inertia over what? Somebody. Capital M. So from this formula, I can find the radius of gyration of any object of any definite shape. For this, we have what? A cylinder, B. This is a cylinder, right? Inertia, is this sphere or cylinder? Is it a sphere again? Okay, sphere. Sphere is what? 2/5 mr square. To find the radius of gyration of this, what do we do? Is to substitute what? 2/5 mr square as what? As I. Am I communicating here? Then divide by what? By M. Or, what do? You compare this, you equate this to be what? M was somebody? K square. From here, M can cancel what? M. Then you can find what? Yeah? K. Are you getting the concept? But let me show you this. We are told that inertia is what? 2 over what? 5, Abi? M what? M R square. We are given that diameter is given as what? What's diameter there? 10 what? Centimeter, right? What we do, convert to what? To meter. Here becomes what? 10 over what? What will here be? 0.1, Abi? 1 what? Meter. But I don't need diameter. I need what? Radius. So what do we do? I will divide by 2, Abi? Hope you are aware that 2R is equals to what? Diameter, right? Diameter, to find radius, what do we do? Divide D over 2, Abi? What's my diameter here? 0.1 over 2. What's the result? 0.0 what? 5. 5 what? Meter. But recall, the radius of gyration is what? Square root of what? Inertia over what? Over M. This becomes what? But don't forget that since I'm dealing with a single body, this M becomes equals to what? To this M. Hope you are aware. For multiple body, we use what? Sum, Abi, of what? Remind me? MI/RI what? Square, Abi, over what? Somebody, M. Are you there? Meaning that when you sum up every mass here, it's same as this mass. Abi? Are you there, somebody? So that means since I'm using for a definite shape, it means that this mass is same as this mass here. So from here, I can say that my inertia is what? Sorry, my K is what? What's my inertia here? Let's go. 2 over 5, Abi? What do you have here? MR squared over what here? M. M can cancel M from here. My K becomes what? Let's go. Square root of what? 2 over what? 2R squared, Abi? Over what here? Over 5. So my K becomes what? Let's finish up this. What's our K now? Square root of what here? 2 times. What's our R? 0.05. Abi? All what? All squared. Over what? Somebody? Over 5. So here becomes square root of what? 0.05 square is what? 0.05 square is what? So 2 times 0.0025, divided by what? 5. Do me a favor, multiply this and divide by 5. What do you have? Multiply 2 by 0.0025 and divide by 5. What do you have? 0.001. So what's the root of this? What's the root of 0.001? So my K is what, yeah? 0. What? 3166 what? 62. Okay, 6 meter. Please put this up as my radius of what? Gyration. Yes, now I said it now. Abi? I say multiply this and divide by 5. Is that what you did? Okay. Another method, option 2. Option 2 is that we are giving I, Abi, as what? 2 over 5, Abi. M what here? R square. Just recall that I is also equal to what? M what? K square, right? Are you there, somebody? To find my K, since we are saying that the entire mass of this sphere is same as M, Abi, and the entire radius of this sphere is same as what? K. I can say that 2 over 5 M what? R square is equal to what? Somebody? MK square. Is it a concept here? Sum of all the inertia here equals to what? This. Mass can cancel mass, Abi. What do you have here? 2. 2R square over what here? 5. Equals to what here? K square. Can I get my K from here? What do we do? We square root what? Both sides. That means my K, right, is equals to what? Square root of what? 2R square over what? 5. Is it the same thing? The same thing. Which one do you prefer? This one. It depends on you. Where are we? Inertia for a solid cylinder about its center. The rotational inertia for a solid cylinder about its center. About its central diameter. Sorry. About its central diameter. about its central diameter. The rotational inertia for a solid cylinder about its central diameter. I'll come back to this. I equals I equals mr squared over what? Over 4 plus mt squared over 12. If r equals to 2 centimeter and t equals to 60 centimeter, find the radius of what? Of gyration. Of what? Gyration.